This is the Chapter 1 and 2 test review, and I've put all of the problems that you'll have in your review assignment onto just a few pages here, and we're going to go through all of the problems, all 26 of them. I'm going to go pretty quickly, so focus on the problems you need help with. Here's problem number 1. Use the order of operations to simplify. 11 times x minus 4 minus 4x minus 7. So the first thing that we'll want to do to simplify this expression is distribute. And we'll end up with 11 times 3x and negative 11 times 4 and negative 4x and positive 7. One thing to think about, when you see a subtraction sign that distributes into multiple terms, it changes the signs of those terms inside the parentheses, right? It's like multiplying negative 1 to those things. So negative 1 times 4x is negative 4x, and negative 1 times negative 7 is positive 7. So be careful when you encounter this in the future. Now, we need to combine like terms. Like terms have the same variable with the same power. So when I see 33x and negative 4x, well, I could take 33x and subtract 4x and get 29x. And then let's look at the constant terms. Negative 44 plus 7. Well, negative 44 plus 7 would give me a negative 37. So we have cleaned this up and simplified as far as possible using the order of operations, and we're done. Let's move on to problem number 2. Problem number 2 says evaluate the expression for r equals negative 3. Remember, the word evaluate means to plug in. So we're going to replace r's, any r's that we see in the expression, with negative 3. That's what we're going to do. Here we go. So I start writing the expression again, like 9, but when I see the r, I replace it with negative 3 in parentheses. And then I continue to write the expression. Oh, I see r again, so I'm going to replace that r with multiplication by negative 3. And so now I think, what's 9 times negative 3? Well, that's negative 27, and that's minus 8. And that's divided by 6 times negative 3, which is negative 18. Cleaning it up further, negative 27 minus 8 is even more negative. It's negative 35. And that's divided by negative 18. Now, a question comes up, is this reducible? Well, it's not reducible by 2 or by 3 or by 4 or by 5 or by 6. It looks like it's not reducible, so I'm going to leave it there. But there is one thing. A negative divided by a negative is a positive. So these two negatives are going to cancel each other. And looks like the result is going to be 35/18. Great. Moving forward to problem number 3. Simplify each algebraic expression. Well, let's go for it. So let's distribute. Once again, we see a negative that has to be distributed into both of these terms. We'll rewrite everything. So 2 times 3y becomes 6y. 2 times negative 3 becomes negative 6. Negative 1 times 4y is negative 4y. And negative 1 times positive 4 is negative 4. Let's combine like terms. So there are the terms with y in them. 6y minus 4y. Well, that's 2y. And negative 6 minus 4 is even more negative. That's negative 10. So that's the result. Let's look at the next. You'll see brackets and parentheses. When we've already used parentheses, the next grouping symbol greater than that we would use is brackets. So let's dig in here. I notice I'm going to be distributing this negative sign into both of these terms in the parentheses. So remember, that's like multiplying negative 1. Let's rewrite everything. 3 minus 3 times 4 minus 7y plus 2. Now, we can combine the constant terms that are in the brackets currently, like 4 plus 2. That's 6. So I'll rewrite it again. 3 minus 3 times, well, 4 plus 2 is 6, and I have a minus 7y. Great. Now might be a good time to distribute the 3 that's in front of the brackets. And so we'll rewrite everything here. I have 3 minus 3 times 6, which is 18, and negative 3 times negative 7y, which gives me a positive 21y. Remember, looking at this really fast, we are not multiplying just by 3, we're multiplying by negative 3. So that's negative 3 times 6, which is negative 18, and negative 3 times negative 7y, which is positive 21y. You could probably imagine a lot of students make mistakes at that moment. Now, at this point, I'm going to simply combine like terms. Like, I know that 3 minus 18, well, that's negative 15. And I still have the plus 21y. Some students like to write the term with the variable in it first, and then the constant term second. So this is probably the most efficient way to write the answer, 21y minus 15. Let's move forward to problem number 4. Now we encounter fractions. So we talked about how to add, subtract, multiply, and divide fractions in our lessons together. And so now let's practice that, and we're doing it. We'll notice that these fractions that we're going to subtract and add have different denominators. They have unlike denominators, so you may want to refer back to how we handle that. Now, a couple things about part A is we don't have like denominators, so we can technically multiply to get a like denominator on top and bottom of a fraction or both fractions. I noticed that multiple of 2 is 10, so I could multiply the top and bottom of this fraction by 5. Okay, so that will give me a common denominator of 10. When I do that, I get 5 times 1, which is 5, over 5 times 2, which is 10, and that was a negative fraction that we were starting with, so we'll make sure that we still have it as a negative fraction. Now, looking here, when I subtract another negative fraction, subtracting a negative becomes a positive. So that's going to turn into a plus. This will become fraction addition now because of that. Now, I've got the second fraction, which is 9/10. Okay, now we've got a common denominator. When you've got fractions with a common denominator, we simply do the operations that show in the numerator, and we keep the denominator the same. So like negative 5 plus 9, well, negative 5 plus 9, that's 4. Now we look at our result and we ask, is this fraction reducible? Can I reduce it? And yes, because both 4 and 10 are divisible by the greatest common factor of 2. And so let's go ahead and reduce the top and bottom so we get 2/5. And this is our final answer. Let's look at the part B, 4/9 minus 7/8. We notice the denominators are not the same. So one thing that is nice to do is we can take this denominator of 8 and we can multiply it on top and bottom of this fraction. And then we can take this denominator of 9 and we can multiply it on top and bottom of this fraction. And now we have a common denominator, 8 times 9, which is 72. All right, so that's one thing you can always do to get a common denominator. So let's see what results. 8 times 9, 72. Okay, now 8 times 4 is 32. So I'll write 8 times 4 is 32. Now I'm going to subtract because there's subtraction between the fractions. 7 times 9, which, well, 7 times 9 is 63. All right, at this point, we can take 32 minus 63, and we'll get negative 31? And that's divided by 72. Now that negative we can write in front of the fraction. Remember, negatives can be on top, they can be on bottom, or they can be in front. Typically when we write a final answer, we'll pull that negative out front. And I noticed that 31 is a prime number, and 72 is not a multiple of 31, the prime number, so we can't reduce this fraction any further. Let's go ahead and move forward to problem number 5. Now, so far, problems 1 through 4, we were simplifying algebraic expressions, or evaluating by plugging in a number and simplifying. Now it's time to start to solve equations for a variable. So problem number 5, solve the equation for x, and it says x divided by 2 equals x divided by 4 plus 2. And I see fractions, and so if you want to clear the fractions from an equation, which I highly recommend, you can multiply the entire equation by the least common denominator. So the least common denominator is the least common multiple of denominators. The least common multiple of 2 and 4, well, is 4. All right. So now we can multiply 4 to all of the terms of the equation, okay? And we can rewrite the equation without any fractions. Now, to do this, 4 divided by 2 is 2, right? So I'm going to take this number, divide it by the denominator, and the result I'm going to multiply to the numerator stuff. So 4 divided by 2 is 2, so I'm going to multiply this x by 2. And I'll start to write the equation 2x. Now I run into an equal sign, so I'm going to write the equal sign. Now moving on to the next piece, I have 4 divided by 4, which is 1, and I multiply 1 with x, so 1 times x is just x. And then finishing, I have an addition symbol, yeah, so I'm going to add plus. And now I take 4 and I multiply it with 2 and I get 8. And now I have written an equivalent equation that doesn't have any fractions. Let's go ahead and solve this equation. So I'm going to get all of the terms with the variable to one side of the equation and keep all the constants to the other side. And 2x minus 1x is just 1x. And that equals the only thing that's left, 8. We have solved the equation for the variable x. It equals 8. Let's move on to problem number 6. It says solve this equation for x. Okay, and so we are going to start to isolate x with this linear equation. Remember, a linear equation is where the highest power of the variable is 1. So this is x to the first power. This is a linear equation. So, let's move the constants to one side. And now we'll have negative 8x equals 25 minus 1, which is 24. And then we'll divide by negative 8 from left to right. And then we will now know that x equals, well, 24 divided by negative 8 comes out clean. It's negative 3. Great. Let's move forward to question number 7. Problem 7 says solve the equation for y. What you'll notice is that we have terms with y on both sides of the equal sign, and we also have constant terms on both sides of the equal sign. So choose which side you want to move things to. For example, I'm going to subtract y from the right side to the left side, and then I'm going to subtract the constant 2 from the left side to the right side. This makes it so I've got certain things, the variable values on the left and the constants on the right. So 8y minus 1y is 7y. And 23 minus 2 is 21. And I can now divide 7 from left to right, and I find out y equals 3. Problem 8. Solve the equation for x. 3x plus 2 equals 8. Same idea here, but now I can just look at this and I can say, well, if I subtract 2 and then divide by 3, I have solved for x. So oftentimes you can look at an equation and just say the step process is really fast. So let's go. Subtract 2 from left to right. Now rewrite the equation. 3x equals, 8 minus 2, which is 6. And now divide by 3. And 6 divided by 3 is 2. So we've just found out x equals 2. Let's move forward to problem number 9. Solve this equation for x. This seems to be the most complex of the problems we've seen so far to solve. So let's start. First, since we have multiple instances of the variable on the left and right side, I'm going to distribute. And I get 5x plus 10 plus 2 equals negative 2x plus 12 minus 9. Let's talk about that really fast. Now, here you see I multiplied negative 2 with x, and I got negative 2x, and I multiplied negative 2 with negative 6, and I got positive 12. All right? So that's an important feature to notice. Next, let's go ahead and combine any like terms on either side of the equation. So I see constants that can be combined, like 10 and 2 will make 12, and 12 and negative 9 will make 3. So rewriting this, I get 5x plus 12 equals negative 2x minus or plus 3, I should say. Great. So at this point, I want to get all of my terms with variables to one side and all my constants to the other. I'll do it like this. I'm going to add 2x from right to left. And so I'll then subtract the constant 12 from left to right. I'll rewrite my equation. So 5x plus 2x is 7x. And that equals 3 minus 12, which is negative 9. And then I'm going to divide 7 to finish. And I find my final answer is x equals negative 9/7. Okay, so I know that 9/7 isn't reducible because 7 is a prime number and it's in the denominator, and 9 is not a multiple of that prime number 7. I also pulled the negative out front because there was only one negative, like negative 9 divided by positive 7, so the result was going to be negative. A couple ideas for you. Now let's go ahead and move forward, and we're looking at problem number 10. Solve this one for x. I see multiple instances of the variable. What am I talking about? Well, there's x right here, but there's also x right here, and they're on both sides of the equal sign. So right now is a great time to distribute. Negative 2 times x, and negative 2 times negative 5, and then a plus 3 equals, well, 1 times x, which is just x, and 1 times 1, which is just 1. Let's combine any like terms at this moment to simplify our equation. So I have negative 2x, and then 10 plus 3 gives me 13. That equals x plus 1. And now I'm going to subtract x from right to left to get all my terms with the variable x together, which means I should subtract 13 from left to right to get all of my constants together. At this point, I notice negative 2x minus x gives me negative 3x, and that equals 1 minus 13, which is negative 12. I now divide by negative 3, and I now know my solution. Well, a negative divided by a negative is a positive, and 12 divided by 3 is 4. So this will be my result. Moving forward to problem number 11. One positive number is 5 times another number. The difference between the two numbers is 1,228. Find the numbers. So we're encountering word problems where we have to create an equation, and we have to solve it for the variable from the word problem. So let's just begin one sentence at a time. One positive number is 5 times another number. Well, I could call the two numbers we're talking about x and y, right? So if I was talking about what x is 5 times the other number, y. All right, so I know x equals 5 times y. Now, you're the one that chooses the variable names. I chose x and y for my two numbers. You could have chosen a and b or m and n. That is your decision. Now, let's look at the second sentence. The difference between the two numbers is 1,228. Meaning, if I took x and I subtracted y, then I would get 1,228, because remember, the word difference in math means subtraction. So I'm going to subtract one number from the other to get 1,228. Great. So now that I know these two things, well, I could do a little substitution. Because I know that x is 5y, I can take this x right here and replace it with 5y. So I'm going to rewrite the bottom equation that I wrote, but I'm going to rewrite it as 5y minus y equals 1,228. Why did I do this? Because we need to have only one variable if we want to solve one equation, right? So I need to make it so my equation only has one variable instead of two variables. You'll notice the equation I just wrote, it has only one variable, y. And if I take 5y and I subtract 1y, that gives me 4y. That equals 1,228. And now if I divide by 4, I have solved for y. And 1,228 divided by 4. I'm going to grab a calculator really quick so I don't have to think too hard this morning. Okay. First time we're getting out our calculator. Awesome. So I notice, well, that result is 307. Okay, I have just found one of the numbers. How do I find x then? Well, you'll remember we had a statement that set x and y in a relationship with each other. X is 5 times y. So to find x, we're going to multiply 5 times y, which is 307. 5 times y gives me 1,535. 1,535. Wow, so I now know what x and what those two numbers are. And you could check this really fast. You could take 1,535 and subtract 307 and see if that equals 1,228. And in fact, it does. And they want me to write as a final answer the two numbers in increasing order, right? Increasing order means the smallest first and then the bigger one second. So we're going to write 307 as our first answer and 1,535 as our second answer. We're ready to move forward into problem number 12. And here it is. When 2 times a number is decreased by 4, the result is 2. Which equation models the problem? Is it this one, this one, this one, or this one? Well, I suggest just like looking at the statement, right? And don't even look at the options. Just see, can I write what they're saying? When 2 times a number, okay, like let's call the number x. We'll use the variable x. 2 times that number. When it's decreased by 4, the result is 2. All right, so I just wrote the statement as I read the words, right? I read the words, and as I did it, I turned it into a math equation. So I now know what the correct answer is. So I'm going to answer, oh yeah, the correct answer is this first one here, right? Because it's the one that actually matches. Now, let's take that equation and we'll solve it for the variable x, right? So we're going to take 2x minus 4 equals 2. So let's go through that process really fast. Let's add 4 from left to right. And we end up with 2x equals 6, right? 2 plus 4 is 6. And then we'll divide by 2 on both sides. And we find out, wait, that means x equals 3. All right. All done with problem number 12. Let's move on to problem number 13. Olivia can type 220 words in 4.5 minutes. At this rate, how many words can she type in 22.5 minutes? Well, I would create a proportion equation. So I could say, well, the amount of words x that she can write in 22.5 minutes has to equal, well, the 220 words that she can type in 4.5 minutes. So I can create two fractions and set them equal to each other. Their rates, x over 22.5 equals 220 divided by 4.5. Now, to solve for the variable x, currently it's being divided by 22.5, so I could multiply 22.5 on both sides of the equation, right? I'm just going to multiply 22.5 on both sides, boom, boom, and I've got it. Okay, so that makes it so, these things fight and die, boom, boom, they cancel. And we've gotten x alone. And so now I'm going to take 220 divided by 4.5 and multiply that result by 22.5. And I get an integer. It equals exactly, it equals exactly 1100, 1100. So Olivia can type 1100 words in 22.5 minutes. I don't know, is that pretty good? That's a pretty good rate, pretty good speed, I think, of her typing and her keyboard. So let's move on to problem 14. The perimeter of a triangle is 62 inches. The second side is 8 inches more than twice the first side, and the third side is 18 inches less than 3 times the first side. Find the lengths of the three sides of the triangle. Well, as we approach this word problem, it's a geometry problem. We're talking about a triangle, so we should draw a diagram of a triangle right now. All right, so I'll do that really fast. So here's just a general triangle, right? This triangle you could have it as any shape that you want to, okay? So you can just like write it like that. Great. Now, let's start thinking about the side lengths. There's some key details, like the second side is 8 inches more than twice the first side. So I'll call the first side, I'll call it x, right? So we'll use the variable, whatever variable you want. You can choose x with me if you like. Now, the second side, we now know that second side is 8 inches more than twice the first. So it's going to be double x, right? Twice the first side plus 8. Okay? Now, let's look at the next statement, right? The third side is 18 inches less than 3 times the first. All right, so 3 times the first side, we called the first side x, so 3 times x, but 18 inches less than that, so I'm going to subtract 18. I now have my 3 expressions for the 3 sides of this triangle. Now, you'll recall from our lessons that the perimeter of a triangle is equal to the first side length plus the second side length plus the third side length. We said perimeter equals A plus B plus C. So why am I getting out that formula? Because they told me information about the perimeter of a triangle. Look, they told me the perimeter of a triangle is 62 inches. So that's why I'm getting out the perimeter formula, and I'm going to use it. So let's input the things that we know for the perimeter formula. For example, P, capital P perimeter, that's 62. And it equals, well, the first side, which we called x, plus the second side, which we called 2x plus 8, plus the third side, which we called 3x minus 18. Well, we now have a linear equation with only one variable, and we can solve that linear equation for x. And it actually goes very fast once we start combining like terms. So I'm going to rewrite this once again. 62 equals, well, let's combine all the x terms with addition. 1x, I see 1x plus 2x plus 3x, and I add them together to make 5x. And now let's look at the constant terms. I see a positive 8 and a negative 18. So I can add them together, 8 minus 18, well, that gives me negative 10. Great. All right, well, there's only 2 operations left to do to solve for x. We just need to add 10 to the other side, and then divide by 5. So I'll do that. I'm going to add 10 from right to left. And I find out that, well, 62 plus 10 is 72. I'll write it down here. 72 equals 5 times x. Now I'm going to divide by 5. And I've got my answer. I see a quick mistake that I made. 1x plus 2x plus 3x is definitely 6x. There we go. And so quickly, I make the adjustments so that I don't make a big mistake here. There we go. And that means x, the short side, equals 72 divided by 6, which is 12. There you go. Okay, so now we know the short side of this triangle. Okay, so the first side length is 12. Now what we can do is take that knowledge and plug it in for the second side length that we wrote. So this is 2 times 12 plus 8, right? X becomes 12. And 2 times 12 is 24, and 24 plus 8 is 32. So that's the length of the second side. And now let's take 12 and plug it in right here for x. 3 times 12 minus 8. Well, 3 times 12 is 36, and sorry, minus 18. 3 times 12 minus 18. 36 minus 18 gives me 18. All right, so we have found the third side length. And so now here are the 3 side lengths of the triangle separated with commas, okay, and in terms of inches. So these are inches in length. Moving forward to problem number 15. A painting is on sale with 15% off. Its current price is $467.50. What was the painting's original price? Great. You can create a little equation. It's pretty fast. So if we take x, the painting's original price, and multiply it by, well, 0.85. And you might ask, why 0.85? Well, 15% off of 100% is 85%. All right? Let me say that again. 100% is its full value or original price. And if we subtract off 15% from 100%, we now have 85%. Okay? And I know if I take 0.85 and multiply it with x, well, that would give me the sale price, which is $467.50. Okay, so we now have an equation that we can solve for the variable, and you'll notice it's really fast to solve. All we need to do is divide off the 0.85 that we were multiplying with x. So we're dividing off 0.85, and we find out x equals, well, we'll get out our calculator and do a quick computation. And we get 550. Great. So $550 was the original price of this painting, which makes sense because, if you had a $550 painting, okay, and you took 15% off, well, it seems like that price would probably be somewhere around $467.50. That seems like a reasonable answer, and in fact, it's the right answer. So always kind of think through, does my solution make sense for every problem that you solve in this math class? Great, let's go ahead and move forward to problem number 16. A painting is on sale with 35% off. Its original price was $750. What is its price on sale? Great, so we now, this time, it's a little different. We know the original price, okay? So $750 is what we're starting with. And if it's 35% off, well, you could think, what's 100% minus 35%? Well, what percent are we actually paying? And the answer is we're paying 65%. Okay, so you could multiply the original price by 0.65, right? Turning the percent into a decimal. And now multiplying these together will give you $487.50, right? The answer comes out looking like this, but of course we're talking about dollars, so we're going to put the nearest cent, the nearest hundredth, and turn it into the dollar symbol. So the painting sells at this sale price for $487.50. All right. we're ready to move forward into problem number 17. Problem 17 says the percent change from 3.5 inches to 10 inches is blank. Now, this problem is as simple as taking the final number and dividing by the original number. Okay, so we're going to take 10 and divide by 3.5. Okay, there's going to be one last thing to do at the end, but this is how easy it starts. Okay, so 10 divided by 3.5. Okay, and we're rounding it to one decimal place after we turn it into a percent, right? So right now I'm going to write it as a decimal, 2.85714. Okay, so that's what I get. Now, there's one thing to do at this point, and that's to subtract off 100%. Okay, so subtracting off 100% is subtracting off 1. So I'm going to subtract 1 from the result that I got. Okay? And so I end up with 1.85714 like this, right? Dot, dot, dot. And why did I subtract off 100%? Well, because the percent increase from 3.5 to 10, well, from 0 to 3.5 is that 100%, so it can't be included. So I'm subtracting off 100%. Now, to turn this decimal into a percent for my final answer, I have to move the decimal place 2 places to the right. Yeah, so this decimal place moves right there, and I've got my answer. It's 185.7%. Okay? Now, if you want to check this and make sure you're correct, you could take 3.5 and multiply it by 1.857, ish, because there's stuff after it, right? And it should give you about 10 back, right? So you can check to make sure you were right on this problem, okay? And there we go. Let's go ahead and move forward into problem 18. A painting is on sale at $600. Its original price was $750. What percentage off its original price? Fill in the blank with a percent. So let's start with the original price and subtract off the sale price. Okay, so let's take the original minus the sale, and we're going to find that difference. And we get 150. At this point, we're going to take the change, the amount of change, and divide it by the original price, which was 750. So I'm going to take 150 and divide off 750, and that gives me my final answer. Which I get 0.2 as my answer. Well, we've got to turn that into a percent, right? So let's go ahead and turn 0.2 into a percent. We'll move the decimal place 2 places to the right, and any empty spaces will get a 0. So I see that 0.2 is 20% off. Okay. So if something was originally $750 and is now $600, that means you got a 20% discount for the sale. Problem number 19. Your friend has a basketball goal in his driveway with a rectangular concrete playing area with length 22 feet and width 28 feet. The playing area for the game is blank square feet. Well, let's create a little diagram. And this is just a rectangle, right? So they said rectangular concrete playing area. and it's a length of 22 feet, width of 28. So you could think, oh, 22, 28. Well, how do you find the area of a rectangle? You multiply length times width, right? This was our formula for the area of a rectangle. Let's input the things that we know, like the area would then be the length of 22 times the width of 28. And 22 times 28 is 616. Okay, now the length is a dimension of feet, and the width is a dimension of feet. And if we multiply feet times feet, that gives us feet squared, right? Feet times feet is feet squared. So when you input this for your answer, you input 616, and you notice it says square feet at the end because we multiplied feet times feet. Problem 20, the length of a rectangular pool is 6 meters less than twice the width. If the pool's perimeter is 78 meters, what is the width? Well, here in this problem, I want to take this information, right, and just write it. So we've got these options, right? We don't know which one it is. I recommend just reading the sentence and trying to write the equation, okay? So first of all, we're talking about the length and the width of a rectangular pool. So maybe I create a little diagram of a rectangle. Okay, here it is. And I've got information about the width, but the length, it says, is 6 meters less than twice the width. So I'm going to write the length as 2 times the width minus 6. All right. And now we have information about the perimeter. So when they tell me the perimeter of this rectangular pool is 78 meters, I immediately think, wait, well, I've got the perimeter formula, which is perimeter equals 2 times the length plus the width. Now let's input the things that we know. Well, perimeter P is 78 meters, so I'll replace P with 78, and that equals 2 times the length, which we said is 2W minus 6, but then I add the width W. And now let's go ahead and see, can I combine like terms to kind of clean this up? 78 equals, well, 2 times 2W plus 1W is 3W minus 6, like that. Does anything so far look like what I've just written? Well, I've got 78 right here. And then I've got 2 times 2W minus 6. Well, I've almost got stuff like that. Maybe I should distribute and see what happens. So I'm going to distribute this in, and I get 78 equals, well, 6W minus 12. And looks like I don't see the option that would be equivalent to this outright. I see 2W plus 2W would just be 4W. Well, this is 4W plus 2W, which gives 6W, and 2 times negative 6, which gives negative 12, and that equals 78. This is the correct answer. Okay. So here's the correct answer. And it's equivalent to what I wrote here. In fact, I simplified it a lot further. Okay, so there it is. Now, we could take that solution, 78 equals 6W minus 12, okay, that equation, and we can solve it for W. So I can add 12 from right to left. I get 90 equals 6W. I could divide 6 from right to left, and I now know that the width W, okay, is equal to 15. So I know W equals 15. Okay. And that's what they asked me for. They want me to solve the equation to find the width of the pool. So, yep, I'm going to say, well, it's 15 meters is the width of the pool. Let's move forward. Problem 21, and here we see a word problem. This is a uniform motion problem where we know rate times time equals distance. So I've created a little table to work with. I just did this right before I started this review. So you would do the same thing if you encounter this, if you want to organize the information from the word problem. So you would create a table equivalent to what you see here. Now, it tells me some stuff like Jay drives 50 miles per hour. Okay, so, we're talking about two people, Jay and Holly. So I'm going to just start to organize this table a little, and I'm going to say, well, I've got Jay and I've got Holly. And they just told me their rates. Rate is the speed. So Jay's rate is 50 miles per hour, and Holly's rate is 47 miles per hour. And now they started at the same spot and drove in opposite directions, right? So maybe you draw a little diagram really fast. They started in the same spot and they drove opposite directions like this. Now, after some time, they were 1,406.5 miles apart. So the total distance they've gone as they've traveled is 1,406.5 miles. So, that is the total distance of both of them combined together. I can put that right here, 1,406.5. Now, after some time, right, they were that far apart. How much time has passed? We don't know how long they've been traveling. Let's call that time t. We'll use the variable t, and we don't know what it is. So that's what we're going to try to find. Now, remember, rate times time is distance. So I can multiply J's rate times the unknown time, and I get 50t. And then I can take Holly's rate and multiply it by the time and write the total distance as 47 times t. Okay, and now the important thing is this column right here that we have organized, because I can take the top row and add it with the second row and set it equal to the bottom row like this, right? Because I know the total distance for both of them will be 1,406.5. So at this point, I'm going to write the equation out. I'm going to write the 50t plus 47t equals 1,406.5. And now I have an equation that I can solve for the time t. It actually will go very fast because 50t plus 47t is 97t, and that equals 1,406.5. And now all I need to do is divide 97 from left to right. Okay, so we've now solved for t, and we get exactly 14.5. 14.5. Well, what are we talking about? Time is in hours. We're talking about things in miles per hour, right? Miles per hour. Time t is in hours. Okay, so it'll take them 14 and a half hours of driving to be that far apart from each other at the current rates that they're going on, their average rates. Okay, so after 14.5 hours, Jay and Holly were that far apart. Well, here's problem 22. It's also a uniform motion problem. Distance equals rate times time. Two cyclists, 48 miles apart, start riding toward each other at the same time. One cycles 3 times as fast as the other. If they meet 2 hours later, what is the speed in miles per hour of the faster cyclist? Well, it seems to me like we're dealing with somebody who's going slower and somebody who's going faster as a cyclist. So I'll put the slow one and the fast one. Now, they start 48 miles apart, right? So here they are, 48 miles apart, and they start riding towards each other. One cycles 3 times as fast as the other. So talking about the rates, well, I don't know their speed, but I know that if I call the slow one X, the fast one is going 3 times as fast as the slow cyclist. They're going 3 times as fast. If they meet 2 hours later, oh, they just told me the time t. So I can write 2 for the amount of time. They're traveling for 2 hours. Uh, what is the speed of the faster cyclist? Cool. So I'm going to write 48 miles for the total distance here because that's how far apart they are from each other. And I'm going to multiply, the rate times the time to get each distance, right? So x times 2 gives me 2x, and 3x times 2 gives me 6x. And I'm going to take this column and add the top rows together and set them equal to the bottom row. And I'll write that equation out. I have 2x plus 6x equals 48. And this all goes very fast now. 2x plus 6x is 8x. That equals 48. And if I divide 8 from left to right, then I end up with x equals 6. All right, now we had to think back. What were we saying x was? What did x represent? Well, x represented, you'll see right here, well, the slow speed, right? The bicyclist who is going slow. And so they're asking, what is the speed of the faster cyclist? Well, I'm going to have to multiply my answer for x times 3 to get that rate, because they were going 3 times as fast as the slower bicyclist. So I'm going to multiply 3 times x, which is 3 times 6, which gives me 18. And we're talking about miles per hour. All right, so the faster cyclist must have been going 18 miles per hour. Great. Let's go ahead and look at problem number 23. You wish to invest $1,300 over 1 year into 2 accounts paying 5% and 6% annually. How much should you invest in each to earn $71? Now, I created a table and you can see it. This is the simple interest formula, right? Interest equals principal times rate times time. And so I've put this information into a table. Now, there are 2 different types of accounts that you're investing in. There's the 5% account, right? The account that gives you 5% interest, and then there's the 6% account. Now, you're going to invest $1,300 total into these 2 accounts, right? And you don't know how much to put in each one to earn the total interest of $71. So this is the thing that's variable. But you do know that if you put X amount into the 5% account, then the amount that will go into the 6% account is the total minus X, right? So here's the idea. You're going to split $1,300 between these 2 accounts. So if you put X in this account, well, this account will be the 1,300, subtract out the X amount that you put here. So this is how you set it up. Now, let's move forward. Let's talk about the rates. Well, the account gives 5% interest, so we'll turn the percent into a decimal, 0.05. And then for the 6% account, yes, that would be 0.06 as a decimal. And how long are you investing for? The time is in years, right? We always have our investment time in years. And you wish to invest that for 1 year, right? So only 1 year. Well, great. That makes things easy because time is 1 for both accounts. So if you multiply principal times rate times time, that will give you the interest here. Okay. Now, well, x times 0.05 times 1, that will be just 0.05x, because multiplying 1 keeps it the same. Okay, and so now let's do that for the second account, the 6% account. We'd multiply 0.06 times 1,300 minus x. And the total interest earned has to add to $71. So we will put $71 right there. Now, this is the important column of information to help us set up an equation to solve, because we're going to add the two accounts together and set them equal to the total interest. Okay, so now we have an equation. I'll write it out. 0.05x plus 0.06 times 1,300 minus x equals 71. Now, you're going to work on your solving skills, right? So we just start solving. 0.05x plus 0.06 times 1,300 I have to find. And I get 78. Okay, so 0.06 times 1,300 is 78. And then there's a minus 0.06 times x. That equals 71. I'm going to subtract 78 from the left side to the right side, right? I'm going to move those constants together. And then 0.05x minus 0.06x is negative 0.01x. I've combined my terms with x together. And 71 minus 78, well, yeah, that's negative 7. And now I'm going to divide by negative 0.01, right? Dividing by negative 0.01 from left to right. And I get my final answer for x. Okay, that should give me what, 70? Negative 7 divided by 0.01. No, it's actually 700, right? So take 7, multiply it by 100. That's the same as dividing by 0.01. Awesome. So what does this all mean? Well, let's go back. We've just solved for x. X is what equals 700. So what was x? X was the amount of money that we put into the 5% account. Okay, so now I know that $700 will go in the 5% account. And if I take 1,300 minus 700, that tells me how much the rest of the money that I have to put in the 6% account, which is $600. Okay, so there we go. We've now completed the problem. $700 will go in the 5% account, and $600 will go into the 6% account. Moving forward. Problem 24. After robbing a bank in Dodge City, a robber gallops off at 14 miles per hour. 20 minutes later, the marshal leaves to pursue the robber at 15 miles per hour. How long in hours does it take the marshal to catch up to the robber? Well, they're talking about galloping, so my assumption is they must be on horses, which makes sense because, like, you know, the robber leaving at 14 miles per hour, it seems like they're on a horse, and that's the speed of the horse, and then the marshal is going a little bit faster. Let's start to organize this information in our table. So we're talking about a robber and a marshal. And, well, they told me their rates. The robber is going 14 miles per hour. And the marshal, their rate is 15 miles per hour. Okay. Moving forward, time. Well, that's what they are really asking about. How long in hours does it take the marshal to catch up to the robber? Now, there's something critical here. The marshal doesn't leave until 20 minutes later. So the marshal's leaving 20 minutes after the robber does. So robber got a head start. So if the robber's time is t, then, well, the marshal's time, would it be t plus 20? Right? T plus 20 right here. Boom. Because, uh, well, there's an issue. Yeah, this is the hard part because we're talking about minutes, right? Minutes, but everything's in rates in terms of hours. So I think we need to convert minutes to hours. 20 minutes, that's 1/3 of an hour. Okay, 20 minutes times 3, 20 times 3 is 60. That's 60 minutes in an hour. So we've got 1/3. So really we have to take t and either add or subtract 1/3. Okay, let's try subtracting. So at this point, we are going to have 14t, right, for the distance of the robber, and then 15 times t minus 1/3 for the total distance of the marshal. And we do not need this spot right here because their total distance that they both travel is going to be equal to each other. All right, so we're going to set these pieces equal to each other to solve. And so I write the equation 14t equals 15 times t minus 1/3, and I solve this equation for time t. We distribute, and we get 14t equals 15t minus, well, 15 times 1/3, that's 5, right? 1/3 of 15 is 5. And now I can, subtract. I can subtract 15t from the right side to the left side like this. And I find out that 14t minus 15t is negative 1t, and that equals negative 5. And now we need to solve for t, so I have to divide by negative 1 across the equation, and I find that t equals 5. So it should take 5 hours for the marshal to catch up with the robber if the robber had a 20-minute head start and the marshal was going 1 mile per hour faster than the robber. Great. Moving forward, we have problem number 25. A man invests his savings in 2 accounts, one paying 6% and the other paying 10% simple interest per year. He puts twice as much in the lower yielding account because it is less risky. His annual interest is $704. How much did he invest at each rate? Well, let's dive in, and we're talking about, once again, simple interest. And simple interest is the principal times rate times time equals interest. We've got 2 accounts again. One is a 6% account, and the other one is a 10% account. He puts twice as much in the lower yielding account because it's less risky. Okay, so if he puts X amount in the 10% account, well, he's putting double that in the 6% to reduce his risk. Okay, and now we know that the rate, well, of the 6% account will be 0.06, and the rate of the 10% account is 0.10. We always turn percentages into their decimals. And how long is he doing it for? Well, do you see in the problem how long he's deciding to? Oh, well, it's annual. So we know his total annual interest. So we're just talking about 1 year again. So the amount of time is just 1 year. Well, let's multiply the principal times the rate times the time to get the interest. For example, I have 0.06 times 2x, right, times 1, which I can clean up. 0.06 times 2 is 0.12, right? It's just like multiplying 6 times 2 is 12, so 0.06 times 2 is 0.12. And now looking at multiplying the stuff for the 10% account, we've got x times 0.10 times 1, so we end up with 0.10x here. And we know the total annual interest is $704, so we're going to put 704 right here. And now let's focus on this column that we just found, because this is going to be the equation that we can solve. We'll write the equation quickly. We have 0.12x plus 0.10x equals 704. Well, let's combine like terms. 0.12x plus 0.10x, that's 0.22x. And now we will divide by 0.22 from left to right, and we have solved for x. It's 3,200. All right? So we've got a solution for x, but now we have to think, what did x represent? Let's go back. X was the amount of money that we put into the 10% account, right? So to find the amount that went into the 6% account, I'd have to double it, 2 times x. I'm going to multiply this result by 2, and I get 2x equals 2 times 3,200, which is 6,400. Right, 2 times 3,200, which is 6,400. In other words, $6,400. Okay, so let's write our final answer, and we need to make sure not to accidentally swap the two answers. Your answer is total in the account paying 6% interest. Well, the 6% interest account was the larger amount, and that was the $6,400 that went into the 6% account. And the amount going into the account paying 10% interest, well, that was the $3,200 that we originally found. Great. And to finish, we have problem number 26. You are going to drive 480 miles today at an average speed of 60 miles per hour. Thus, you are going to drive for a total of blank hours. The diameter of the wheels on your car, including tires, is 25 inches. Thus, each wheel is going to turn a total of blank times today. Great. Well, there's a couple things to solve this problem. The first part's very simple. If we're traveling 480 miles and we're going 60 miles per hour, well, we could just take the 480 and divide the 60 to find the amount of time that we'll be driving. All right, so this is the easy part. We take 480 miles divided by our rate of 60 miles per hour, and that tells us, hey, we've been traveling for 8 hours today. That's how long we're going to travel today. Okay, so there we go. We've completed that part. It's 8 hours. Now, this next bit of information, the diameter of the wheels on your car, including tires, is 25 inches. That piece of information will help me to find the circumference of the wheel. Okay, so the circumference of the wheel is 2 times pi times the radius. Well, if the diameter is 25 inches, the radius is half of that. Okay? Now, there's two formulas for circumference. Circumference equals 2 times pi times the radius, but 2 times the radius is the diameter, so oftentimes this formula is written pi times the diameter, because 2 times the radius is the diameter. Okay, so we're going to take pi and multiply it by the 25 inches, right? That'll tell us the circumference of the wheel. Okay, so we'll just keep it as 25 pi. Pi times 25 inches, the 25 pi. Now, to know how many times our wheel is going to turn, we've got to do unit conversions from miles into inches, right? So we've got 480 miles that we're starting with. That's the total distance that we're traveling. Now we have to multiply that by the amount of miles and feet. So I'm going to convert from miles to feet and then to inches. Well, we know there are 5,280 feet per mile. And then we've now done the conversion to feet. Now we need to convert feet to inches. So we know there are 12 inches per foot. Now what's great is, this unit conversion, miles on the top kills miles on the bottom. They cancel. And feet on the top kills feet on the bottom. And our resulting dimension, our unit measurement is inches. And so I can multiply 480 times 5,280 times 12. And, dividing by 1, doesn't change the answer, right? Dividing by 1 here and here. So it's just 480 times 5,280 times 12. And I will quickly calculate that. And, well, I get 30,412,800 inches. Okay, that's the total distance I traveled. So 30,412,800 inches. Now, to find out how many times my wheel is going to turn, right? Each wheel is going to turn a total of how many times? All I need to do is take the total distance in inches and divide by the circumference of my wheel. Okay, so my final answer will be 30,412,800 divided by 25 pi, the circumference of my wheel. Okay, and so computing that, well, that gives me, if I round to the nearest revolution, 387,228 times. Okay, so that's how many times my wheel turns when I drive 480 miles if my wheel has a circumference of 25 pi. And that, problem 26, was a nice challenge problem for your brain. And we have now concluded the entire review for chapter 1 and 2. All right, best wishes as you prepare for that test. And please reach out with any questions that you have. Have a great day.